Okay, today we're going to talk about the angles of triangles. What am I going to learn here? You're going to learn how to classify triangles by their sides and by their angles, and we're going to find the interior and exterior measures of the triangles. Okay, so the first thing we're going to look at is classifying by the sides. If there are no sides that are the same, then it's a scalene triangle, no congruent sides. If two sides are the same, you can see the marks, then it's an isosceles triangle. If all three are the same, then it's an equilateral triangle. Now we're going to look at classifying them by the angles. If all of the angles are less than 90 degrees, which means they're acute, that is an acute angle, an acute triangle. If one angle is a right angle, then it's a right triangle. And only one can be right, because if you had two, that would be 180 and you'd be done with your triangle. Okay, obtuse means you have one obtuse angle which is greater than 90 degrees. And if you have three congruent angles, then it's an equiangular triangle, which is, we call them equilateral triangles, but if they're equiangular, if you hear that term, you'll know that that means they have all the same angles. So we're going to look here. Okay, so we're going to look at this triangle in these beams, and it says classify it by its size and by measuring its angles. So the first thing that I'm going to do is I'm going to look at this. It's marked that these are equal. So this is an isosceles triangle. And then I'm going to measure the triangles, so the angles. So I would take my protractor. I would line the line on my protractor up and make sure that the center is right there. Then I would look at this line, and I can see that it's less than 90. So I would use the smaller number, and I can see and I can find all my measurements. You would do the same thing here, line it up, put the center there, line it up, put the center there, also look at the smaller number, and I can see 55 degrees, 55 degrees, and 70 degrees. And we'll learn why those are the same later on, so that's a cool thing to find out. And that means it's an isosceles acute triangle, okay? Or an acute isosceles triangle. All right, so in this one they want you to classify it by its sides, then determine whether it's a right triangle. So the first thing I'm going to do is I'm going to do the distance formula. So I'm going to find PQ, and I'm going to use the distance formula, and that would be PQ would be 6 minus negative 1 squared plus 3 minus 2 squared. Square root of 6 plus 1 is 7 squared is 49, plus 3 minus 2 is 1, so it's 1. So that equals the square root of 50. Okay, so I'm not going to do the distance formula for each one of these. I'm going to give you the answers. So PO equals the square root of 5. And for this kind of a problem, you don't need to find exact answers, or these are the exact answers. You don't need to simplify or find the estimated. You can just give these, because that will tell you if they're equal or bigger or less. And then OQ is equal to square root of 45. So right away we can see that all the sides are a different length, so it's scalene. Okay? Now we're going to look at, we want to know if it's a right angle. So first of all, I'm going to say, I'm guessing that this is the one that I'm checking, because that's the one that looks most like a right angle. So how do I figure out if it's a right triangle or a right angle? So the second thing I'm going to do is find the slope of OP. Now you can use the slope formula, or you could just do this. And it is up 2 over 1, and it's a negative slope, so it's negative 2. And then I'm going to compare that to the slope of OQ. And that one would be, you could do the 2 points like this. So it's 3, positive 3 over 6. So positive 3 over 6 would be 1/2. And those are perpendicular, because negative 2 times 1/2, those are opposite reciprocals, equals negative 1. So those are perpendicular, which means it is a right triangle. So it is a scalene right triangle. Okay, so that's how you would classify that. All right, so now classify the triangle by its sides and by measuring the angle. So if you wanted to, you would look at this. I can see that there's one obtuse angle, and these are not the same, so therefore it's an obtuse scalene triangle. For this one, you would want to check with your protractor to see that this is 90 degrees, and these are not the same, and these are not the same, so therefore it's a right scalene. And then this one has two matching sides, and they're all less than 90 degrees if you measure, and so these are acute isosceles. Okay, and you can go back and measure these in your book if you want to check that out. Alrighty. So classify triangle ABC by its sides, determine whether it's a right triangle. So you could find the distance. An easy way to do this would be to quickly graph it. You can find the length of each one either by the distance formula or by doing the Pythagorean theorem. So this is 1, 2, 3, 4. This is 1, 2, 3, 4. So 4 squared plus 4 squared equals, we're going to call that x squared. So 16 plus 16 is 32 equals x squared. X equals the square root of 32. And you can do that for each side really quickly. And mainly you'd be checking these two to see if these are right. So right away this is 3 and this is 4. So they're not equal. And so it's a scalene. Okay. And then the next thing I'm going to want to do, scalene, I'm going to want to find out if this is a right angle. So what I'm going to do is I'm going to clear it off so that I can see everything. Okay. And see if it's a right angle. So I'm going to find the slope. Okay. So this one is 1, 2, 3, 4, 1, 2, 3, 4. So the slope of this is 1. Okay, and then the slope of this is 1, 2, 3, 4, 1, 2, 3. So this is definitely not a right triangle because those are not opposite reciprocals. It would be 1 and negative 1. And so that is just a scalene acute angle. Okay. All right. So finding the measures of triangles. When the sides of a polygon are extended, other angles are formed. The original angles are called interior angles because they're inside the triangle. The angles that form linear pairs with the interior angle, so this is a linear pair right here. This is the exterior angle because it's outside the triangle. This forms a linear pair here. This is the exterior angle. And this forms a linear pair here. That's the exterior angle. Okay? Alrighty. So, in your journal on page 326, it tells you this rule. The triangle sum theorem says the sum of the measures of the interior angles of a triangle is always 180 degrees. Okay, so measure of angle A plus B plus C equals 180 degrees. All right. So, for certain theorems, you may need to add a line or a segment or a ray to a given diagram. An auxiliary line is used in the proof of the triangle sum theorem. So what they did was they said they want to prove that angle 1 plus angle 2 plus angle 3 equals 180. So they added this line here, and they made sure that it was parallel to AC. So they added BD and made it parallel to AC. Now we're going to go over this in a minute. Then they're going to show that this adds up to 180. And then we're going to do angle 1 equals angle 4, and angle 5 equals angle 3, and then we're going to do substitution. Okay? So here's the steps. We're going to draw this by the parallel postulate, so I can create one. Then we're going to say that angle 4 plus angle 2 plus angle 5 equals 180. And they use the angle addition postulate and the definition of a straight angle. So they added 3 angles together to create the straight angle of BD. Okay? And they equal 180. Then they said angle 1 equals angle 4. Well, think of this as a transversal. cutting two parallel lines, these are alternate interior angles. And the same is true for angle 5 and angle 3. So now we can prove that those are by alternate interior angle theorems. Well, then we're going to switch to measures because we need to get back to measures for 180. So we just change all those from congruency to measures, and that's the definition of congruent angles. And then what we're going to do is we're going to take this statement here, and we're going to substitute the 1 for the 4 right here, and we're going to substitute the 3 for the 5, which was right here, and plug those in, and now we have what we were looking for, substitution property of equality. And these were the plans that we used to create that. Okay? So that's the way you put the proofs together. Okay, so the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So they're saying that this angle equals this angle plus this angle. Okay, now how do you prove that? So remember that angle A plus angle B plus angle BCA, that's this angle here, equals 180 by the triangle sum theorem. Okay, the triangle sum theorem. And we know that angle BCA, that same angle here, plus angle 1 equals 180 by the definition of a linear pair, because they are a linear pair. Okay? Okay, now we're going to use substitution, and we're going to say angle A plus angle B plus angle BCA equals angle BCA plus angle 1. Because they both equaled 180, therefore they can equal each other, right? So then I'm going to subtract angle BCA from both sides of the equation, and I get angle A plus angle B equals angle 1. And so that's a quick little proof, and that would be the subtraction property of equality, and that would prove that they are equal. Okay, so let's use that to solve a problem. So since we know now that this exterior angle is equal to the sum of the non-adjacent, this is the adjacent angle, the non-adjacent, we can go 70 plus x equals 2x minus 5. I'm going to subtract x from this side, and I get x. I'm going to add 5 to the other side, and I get 75 equals x. But wait a minute, they're asking me to find JKM. That is this angle. Okay, so now I'm going to have to plug in x. So 2 times 75 minus 5 is 150 minus 5 equals 145 degrees. And you could do a real quick check. 70 plus 75 is 145 as well. All right. Okay, so for this one, we have an exterior angle. They want us to find PQS, which again is this angle. So we're going to go 3x plus 25 equals 2x plus 65. I'm going to subtract 2x from each side. I get x. I'm going to subtract 25, opposite operations, not just what you think, equals 40. Okay, so now that we've got x equals 40, we go 3 times 40 plus 25 equals angle PQS. And so that would be 120 plus 25 equals 145. Okay, and now we're going to double check. 2 times 40 is 80 plus 65 is 145. And we know we got it right. Okay? Alrighty. So make sure you don't just stop at x equals 40, because then you're not getting the correct answer. Okay, so find the measure of the exterior angle. So angle 1 equals 53 plus 53. So angle 1 equals 106 degrees. Okay, 40 plus 5x plus 15 equals 8x minus 5. Combine your like terms, 5x plus 55 equals 8x minus 5. Subtract 5x from each side. I get 3x. I'm going to add 5 to each side. Remember, opposite operations. 60 equals 3x. Divide by 3. X equals 20. So that means this one is 8 times 20 is 160 minus 5 is 155 degrees. Okay, I'm going to go over here and check. 5 times 20 is 100 plus 15, so 115 plus 40 is also 155. So I know I got that right. Okay, a corollary to a theorem is a statement that can be proved easily by using the theorem. The corollary below follows the triangle sum theory. So it's the corollary to the triangle sum theory. The acute angles, that's these two angles, of a right triangle are complementary. In other words, they equal 90. That makes total sense because they all have to add up to 90. So if you go angle C plus angle A plus angle B equals 180, then you've got angle C is 90 degrees plus angle A plus angle B equals 180. Then we're going to subtract 90 from both sides, and that means that angle A plus angle B has to equal 90 degrees. So that's just a quick proof of that corollary. Okay, so find the measure of angle 1. So there's a couple different ways that you can do this. So you do have to solve for x first. So we're going to go ahead and do that. So 40 plus 3x equals 5x minus 10. Subtract 3x from both sides. I get 2x. I'm going to add 10 to both sides. I get equals 50. So x equals 25. So now that I have x, I can do this one of two ways. I can say this is 75, and then I could add them together, and I could say that is 115, and then say this is 180 minus 115, which is angle 1 equals 65 degrees. Or I could calculate this one. 5 times 25 is 125 minus 10 is 115. And then I would use the same calculation I used before. So I want you to know it's either one that you choose, but you do have to solve for x first. You could use the triangle sum theorem, or you could use the exterior angle theorem. Okay, so either one. Now this one, they're giving me a right angle, and so I have to find these two. So I know that these two are complementary. So I go 2x plus x minus 6 equals 90. Combine your like terms. I get 3x minus 6 equals 90. Add 6 to both sides. 3x equals 96. I'm going to divide by 3, and I get x equals 32. So that means this angle is 64, and this angle is 26. 32 minus 6. Then I just do a quick double check to make sure that those add up to 90, and they do. So I'm good to go. Okay? Notice it doesn't take me very long to check the answer. All right, so here's a problem from your journal. It'd be a really good idea for you to try this on your own. Otherwise, let's go ahead and do this together. So it says, in a right triangle, the measure of one acute angle is twice the sum of the measure of the other acute angle. So the other acute angle is x. And the one acute angle, so the first one I talked about, is twice the sum. So you have to remember they're writing it like this, twice the sum of the measure of the angle, the other angle, plus 30. So now, since it's a right angle, I know that these are complementary. So I'm going to go x plus 2 times x plus 30 equals 90. I'm going to distribute, don't forget to distribute, x plus 2x plus 60 equals 90. Combine your like terms, I get 3x plus 60 equals 90. Subtract 60 from both sides. I get 3x equals 30. So x equals 10. So the other angle is 10 degrees. And then this one would be 2 times 10 plus 30 is 2 times 40. And that one would be 80 degrees. And again, I check, and they do add up to 90 degrees. So that should help you get through the homework. Have a great day.